Hi guys, I just want to show you this very nice and elegant experiment for measuring the magnetic field strength between a pair of magnets. So here I've got the magnets, two magnets that are attracted to each other, and there's a wire between the magnets that I can put an electrical current through. The magnets are sat on a balance, and the balance has been set so at the moment with no current going through, there's no apparent mass. So when electrical current passes through, because of the interaction between the electrons in the wire and the magnetic field, they're actually going to generate a force. Now if you are doing A level, you'll be familiar with this equation, F equals BILsine. So what's F, B-I-L, and sine theta? Well, F is the force on the wire, B is the magnetic field strength, I is the current flowing through the wire, L is the amount or the length of the wire that's exposed to the magnetic field, and sine theta, well, the angle is between the magnetic field and the direction of the current flow, which is actually set up to be 90 degrees, and sine 90 equals 1, so we can kind of ignore that for now. If we measure the length of the wire inside the magnetic field, or it's probably, the size of the magnets are around maybe 50 centimeters. So what we're going to do is vary the current and record the force. Now bear in mind the scales are going to give you a mass here, okay? But that mass you can just convert straight into newtons using W equals mg. Now having plotted the force against current, you can get hopefully a nice straight line. You'll notice that as the current increases, the force will increase proportionally. And well, we can say, well, the gradient of this line, using y equals mx plus c, the gradient is actually equal to the magnetic field strength times by the length of the wire that's exposed to the magnetic field. Dividing the gradient by the length is going to give us the magnetic field strength. So I'll just demonstrate now. If I increase the current, okay, hopefully we should start to see that the force increases. So let me increase this. So there we've got half an amp. We're measuring 0.14 grams. 1 amp, 0.23. 1.5, 0.34. 2 amps, 0.43 grams, dial that back a little bit, 2.5 amps, 0.50 grams, 3 amps, 0.62 grams. Let's go all the way up to 4 amps. So 3.5 is 0.71, and 4 amps is going to give us 0.82 grams. So the length of the wire, as I said, is 5 centimeters. So why not have a go, plot this on a graph, and then maybe in the comments let me know what the magnetic field strength of my magnets is. Thanks guys, bye for now.